All right, welcome back. This is our video number 3 of our 3-part series. We will be having a bonus video of this 3-part series, so we should call it 4. But you will soon understand that when you have 3, you automatically have 4. So, we are talking about the scientific method. The scientific method is a generalization of steps one can take to observe phenomena. So, in our first video, we had a scientific model of the scientific method, and it had 5 steps. Okay. The second video showed you the scientific model of the scientific method, and that had 6 steps. This model of the scientific method has 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, this is us understanding that scientists are observing phenomena, but everyone has different eyes, everyone has different brains. They all work the same, which is why we have to create models. We can all clearly see that this is a poster. We can clearly see that this is a poster. We can both confirm that these are 2 posters. So the idea is that we can come to a single conclusion and communicate that conclusion between your peers because of the simple fact that we are observing the same phenomenon. But what if we have a disagreement? What if somebody says, this is not a poster? What if they said that this is a flyer? That is the whole objective of a scientist. It is to describe all the different possible answers and for us to decide together as as a group, as a community. So, in this scientific model, we have the first step says inferring and predicting, guessing or drawing a conclusion about an object or future event based upon observation. So that's super important. Unlike the first two said make a question up. Actually, it said, do you have a question on the first one? The second one said, do you have purpose? And that's where we get into with this inferring and predicting. Okay, it is based upon drawing a conclusion about an object or future event. Now, when you have that object or future event, you're going to want to control. Okay, you want to study how the attributes vary due to varying variables. So what that means is the subtle changes, okay, the differences between what you are predicting, okay, you want to be able to control that. So an example would be weather. Can you predict that it'll snow in Arizona? Well, we have to look at the variables that control snow. In this case, temperature will control whether Arizona will receive snow or not. Here in the valley, there is a very small chance for us to get snow. But if you go up north, where the temperature changes, the environment changes, the control variables are different. Now you have an opportunity for snow as if you were in Flagstaff. Okay, representing data. When you have what you are looking for, you have to organize it into a nice, clear, and concise model for others to understand you. Just like these videos. These are videos, and they are built to represent my voice and my image, and it is also representing time. It wants you to be able to see my voice or see me and hear my voice over time. So that is us representing our data. You're organizing your measurements to make your information easier to use and interpret. This is a lot easier to use. You can use my information because you can press stop, then you can press play. That is the idea. So if you don't understand the control variables about snow, you can pause this video, rewind it, and look at the various control agents to whether it was snow in the valley or not. And this is us again representing that. Experimenting. This is putting all the process skills together in a single activity. So, to make sense of our example, that might simply be Google searching. You might Google search the question, does it snow in Phoenix, Arizona? And you might get a response in the form of what you call a pop-up or a website or a tag or a definition, and it has been controlled by a bunch of previous data, and then you're going to have an answer, okay, because somebody asked that same question before you, in which in this case you'll most likely get the answer possibly. And that's what scientists do. We don't want to confirm anything because we understand that things are changing. We see things change, which is why we're focused on just observing things. We're observing using the five senses to learn about an object, an event, or to collect information about an object. We're not here to tell you yes or no. We're here to say this is the potential, here's the potential to not. That is what we're doing. And in doing so, we are classifying. We're placing objects into events. We're placing objects into groups. We are using common characteristics in order to group things together. So, for instance, it is not snowing in Phoenix often because we can categorize the temperature as it being too hot. So that is a category. We're categorizing Phoenix, Arizona as too warm to carry snow. Whereas we can categorize Flagstaff, Arizona as the right temperatures for snow. Which brings us to measuring. Measuring is determining the length, area, volume, mass, temperature to describe and quantify objects. In other words, it cannot snow in Phoenix, Arizona, right? We classified it as being too hot. Now you're going to tell me what too hot actually is. 76 degrees. It might be 57 degrees Fahrenheit. It might be 27 degrees Celsius. But the idea is now we're going to communicate to describe that object. And notice, I spoke math in a verbal tone. So you're going to have to really use your math skills to communicate objects from one person to the next. So that's our video number 3. I'm Mr. Henson. See you next time.